ready to make a deal?
I'm ready to make a deal. Let's do this.
Okay, so there's this famous probability like paradox or like brain teaser. Have you heard of this? The Monty Hall problem?
I have heard of it. It's been in some movies.
Yes.
I've heard of it.
So the host, Monty Hall, he would have these 3 doors and you would like pick a door. And there would be 2 doors that have something behind them that are called like zonks, which is so corny, like zonk, you know?
Yeah.
They're like goats or something.
Okay.
Which is kind of weird because I like goats.
I was going to say, I'm not sure how I would feel about that because I love goats.
I love goats. I feel like that getting a goat would be a win.
For sure.
They would eat all your furniture though.
That's true.
And climb all over. So it's probably a zonk.
Yeah.
So we're going to go with it that a goat is not what you would desire. So there'd be 2 doors, which behind it would be a zonk/goat. And then 1 door behind it would be the winning item, which often was a car. People wanted to win a car. And like,
I'm not really into cars. Let's make
I'm
it
not
something
either.
else.
What if it was something like everyone would love, like Keanu Reeves?
Oh, 100%. Yes.
What if behind 2 of the doors there's a goat and behind the 3rd door there was Keanu Reeves just waiting to have lunch with you?
I cannot think of a better gift.
I think everyone would
or
love
a better
that.
prize.
Okay, so the famous question is, all right, you pick a door. So you randomly, there's 3 doors, you pick one and you say, that's the one I want. And so then the game show host comes along and says, all right, well, you've selected a door. I, as the host, know what's behind all 3 doors. And I'm now going to come in, open a door, and show you a goat. Then he's going to say, well, would you like to stick with your selection or would you like to switch to the other remaining door? Because there's only 2 doors closed at this point. The one you've chosen and the one that's still standing. And the question is there a strategy to this? Should you switch or should you not?
Should I stay or should I go now?
And it turns out there is a strategy to it, isn't there?
There is, yeah. It turns out that we should switch.
Right. It turns out to be advantageous to switch every time because on average, you're going to win 2/3 of the time if you do switch and only 1/3 of the time if you don't switch.
Right, which is a little bit counterintuitive because it would seem like you had a 50-50 shot if there were 2 doors left. But
Exactly.
The key is, since he knows what's behind the doors, that's what's going to make the difference here.
Right. So let's suppose that we have doors A, B, and C. And the game show host asks you, which door would you like to pick?
Okay, I'm going to go with door A.
Okay, you pick door A. So your selection is door A. And again, this is arbitrary. You could have picked B or C and our discussion would still be the same.
Right.
Okay, what is the probability that behind door A, you have the prize? In our case, that's Keanu Reeves waiting for you to have lunch with him.
1 out of 3.
Right, 1 of the 3 doors has Keanu. What's the probability that one of the remaining doors has Keanu behind it or the prize behind it?
2/3.
Right. There's 2 doors left out of 3 total doors. So there's a 1/3 chance that your selection has the prize and there's a 2/3 chance that the remaining doors, one of them has the prize.
Right.
But now the game show host comes along and he knows what's behind each door. And he has to come along and open a door that has a zonk or a goat behind it. Okay, so suppose the game show host says, you know what? I'm going to show you door C. I'm going to open that for you. And behind that is a goat. Now you have additional information. This probability equaling 2/3 all belongs to door B now.
Yes.
So would you rather stick with door A where the probability is 1/3, or would you rather switch to door B where the probability is now known to be 2/3?
Yeah, I definitely want to go with door B. I want that lunch with Keanu.
Right. So it's in your advantage to switch because the probability that you win the prize if you switch is 2/3 as opposed to staying where the probability is only 1/3.
Right. That's so cool.
I know. It's a little wild, kind of a brain teaser. Cases. In the the case where you have selected the winning door, if you don't switch, you win.
That's right.
If you do switch, when the host comes along and says, I'm going to reveal either this goat or I'm going to reveal this goat, regardless, if you switch, you're going to lose because you're walking home with a goat.
Absolutely. Yes.
So in this case, if you switch, you lose, but if you don't switch, you win.
Okay. And then case number 2, I'm going to choose door B.
What happens here is a little interesting because this time the game show host doesn't get to have a choice on what door he opens because he has to show you a goat. That's the game.
Exactly. Yeah.
So he has to come along and reveal the goat behind door A.
Mm-hmm.
So if you switch this time, do you win or do you lose?
We win because we got to go to door C now. So we're going to get Keanu.
So a switch would be a win this time.
Mm-hmm.
If you don't switch, what happens this time?
We lose.
We would lose. Okay. What if you selected door A?
So if we select door A, this is going to be really the same as the last case. Okay, because now the host has to cross off B. And now if we switch, we're going to go to door C and win.
Right. So we're going to go, in this case again, you switch, you win. So this would be a win. And if you don't switch, you lose. So it's kind of interesting to see now in our little table here, out of the 3 cases that arise when you switch, you win 2 out of 3 of them.
That's right.
If you don't switch, you only win 1 out of 3 of them.
Right.
So it's smarter to switch.
That's right, every time.
Okay, another way that people often look at this is with picturing like 100 doors.
Oh.
If we go bigger, it makes a little more sense. If you have 100 doors to pick from, and let's say you select door A, what's the probability that you have selected the prize of Keanu Reeves?
1 out of 100.
1 out of 100. And what is the probability that the prize lies in one of these other 99 doors that exist?
99 out of 100.
Right. So you're, in this case, you're like, oh man, my odds aren't looking so good. They looked pretty good when it was 1 out of 3.
Mm-hmm.
But the probability that Keanu is in one of these other doors is 99 out of 100. But if the game show host comes along, shows you a goat, shows you a goat, shows you another goat, so all of these doors where he keeps opening and showing you goats, you don't want those doors. Maybe he doesn't open that one. If the game show host has shown goats behind all of these other doors, that means the 99 out of 100 probability all belongs to this one door.
Yep.
So should you stick with your door where your chances of winning are 1 out of 100? Or should you switch to the remaining door standing where your probability is 99 out of 100?
I would like the 99 out of 100, please.
Yes, we're going to switch.
Switch it.
So the moral of the story is switch.
Switch it.
Yeah, you have a better chance of winning.
The following program is brought to you in living color on NBC.
Monty Hall.
Do you want to stay with door number 1 or go with door number 2? Now, is it in your interest to switch your choice?
Yeah. Now, see, most people wouldn't take the switch out of paranoia, fear, emotions. But Mr. Campbell, he kept emotions aside and let simple math get his ass into a brand new car.
It didn't become like a famous like argument or paradox until like 1990.
Wow, recent.
Yeah, it's pretty recent. So 1990, and it was in Parade magazine. There was this column called like Ask Marilyn, which I'm already interested in. Like Marilyn, yes,
Yeah,
I want to
for
ask
sure.
her. In fact, Marilyn, her name is Marilyn Vos Savant.
Oh.
So with a last name like Savant, you know she knows what she's talking about.
Yeah.
So she actually said it's better to switch. And it was interesting because what happened was a lot of mathematicians like wrote into the magazine and were like, this is so wrong.
Really?
And yes. So like tons of PhDs wrote in and they were like, this magazine is mathematically illiterate and this is so wrong. And
How is that possible?
I know, it was insane. And so if this problem frustrates or confuses you or our students, like none of us should feel bad because it's a funky one and it even confused a lot of PhD mathematicians.
Totally.
Yeah.
Wow.
At the end of the day, Marilyn was right. Her last name's Savant. She knows her shit. Let the women do the work.
And the world's smartest woman, Marilyn Mock Vos Savant? Huh? She's so smart we don't know how to pronounce her name. That's how smart this woman is.
Savant was my grandmother's name. Before she married my grandfather's name was Vos Savant.
Vos Savant. But does it have any literal meaning?
It's supposed to mean a wise man or something like that.
Well, that's a coincidence then, isn't it?
Yeah, it's a hell of a coincidence, I think.
It's all over the world now. Trouble is that I'm tired of explaining it to people. And besides which, I never did it that way on the show. What should they do? Should they do or shouldn't they do? I said, I never gave them the opportunity. But this was Marilyn Vos Savant saying that if you did, I can prove to you why it's valuable to you to make the switch.
Switch.
Switch it.
All right, that was fun. Thanks for playing Let's Make a Deal with me.
So fun. Bye.
Bye.
Please welcome Marilyn Mock Vos Savant, ladies and gentlemen.
Well, come on and let me know. Should I stay or should I go? Should I stay or should I go now? Should I stay or should I go now?